I'm Emanuel Tschopp, and I'm a paleontologist at University Nova of Lisbon in Portugal.
I want to know what's happening, what's happening, what's happening this week in science. What's happening, what's happening, what's happening this week in science.
As a paleontologist, what species of dinosaurs are you most interested in? Is it just a broad interest in paleontology and the fossils that are found within the earth, or do you have a very specific interest?
Well, I have a specific interest in dinosaurs, and most of the research that I've done until now is on sauropod dinosaurs, so the long-necked ones. But I don't have a specific dinosaur species that is my favorite.
Do you have a story of how you got interested in dinosaurs and in the sauropods themselves?
Well, I think it's the classical, also paleontologist story that, at least of these times, that I had the topic dinosaurs at school and got really interested in them. As a maybe 8 to 9 year old boy, and somehow that stuck. So that's how I ended up to study paleontology and to become a paleontologist. And then it just so happened that close to where I lived there was a dinosaur museum, and they do have a great collection of sauropod dinosaurs from Wyoming. So it was the easiest group also for me to study once I started doing research on dinosaurs.
So Wyoming specifically is a really amazing area for these sauropods, the long-necked dinosaurs. Do we have any idea why we're finding so many of this particular type of dinosaur in this area?
It's not only Wyoming, but it's the entire west of the United States, so also up to Montana. We find a lot in Utah and Colorado, down to New Mexico. This entire area is very well known for in paleontology, because the layers there that occur on the surface, they are from the late Jurassic, which was the time of dinosaurs and was one of the times when the diversity of these long-necked dinosaurs was the largest during all the time of the dinosaurs. So it's, yeah, if somewhere, then sauropods must have been there.
Yeah, so I just find it interesting, the whole idea that there was vegetation diversifying, there was diversity in the landscape, and so you have this, this kind of variation in how different dinosaurs ended up looking, and so we have this
Yes.
group of these long-necked dinosaurs, and you specifically are involved in a paper that's coming out in PeerJ on the Brontosaurus.
Yes.
But the Brontosaurus has been and then has not been, and now you're saying
It's again. It's here again, yeah.
What's the fossil story of the Brontosaurus?
So the first fossil of a Brontosaurus was found in the 1870s. And was described as a new species in 1879. And the species was called Brontosaurus excelsus. And then at some point, 25 years later, more or less, in 1903, there were new specimens found, or new skeletons found, that were similar to Brontosaurus, but that were also similar to a dinosaur that was named 2 years before Brontosaurus, which is called Apatosaurus. So because this new specimen or new skeleton that they found was somehow intermediate between the two, the researcher at that time thought that the difference between Brontosaurus and Excelsus and the species of Apatosaurus ajax, were not numerous enough or important enough that they could be two different genera. So he proposed that Brontosaurus excelsus had to be included in Apatosaurus and should be called Apatosaurus excelsus. This because Apatosaurus was named before. So for the rules of science in this case, Apatosaurus had priority over Brontosaurus. But it kept to be a distinct species from other species of Apatosaurus. It just was not called Brontosaurus anymore. So yeah, that's the start of the story. And when we come to our study now, where we re-study this entire group of Diplodocids, where Brontosaurus and Apatosaurus are part of, and we re-study it with new evidence still, so more skeletons that came out in the last few years, that helped us to understand much better the diversity in the anatomy of the bones and the differences and everything like that, and allowed us to reassess also this question of Brontosaurus and Apatosaurus. And we saw with two different approaches actually that came to the same conclusion, that Brontosaurus is different enough from Apatosaurus so that it should be its own genus and not just a different species.
Can you talk a little bit about how the skulls are important in this decision or this differentiation between the species?
Yeah, the skull story is interesting because it also has changed a lot during time. So basically, Brontosaurus excelsus, when he was named, was one of the best preserved skeletons of a sauropod dinosaur. But it did not have a skull. But however, because it was so well preserved, it gave a good image of how a sauropod looked like, which was something that people did not, also researchers did not know very well before. Marsh, the famous paleontologist Marsh, who described actually also and named the species Brontosaurus excelsus, he decided to make and publish a reconstruction of the entire skeleton, and took inspiration for the skull, for a hypothetical skull, from another dinosaur that was found in the same area, which is called Camarasaurus. This dinosaur was relatively massively built, as also Brontosaurus and Apatosaurus. So the assumption that they had a similar skull was reasonable at the time.
Right.
However, for the first time in 1915, but then definitely in the 70s, researchers found out and confirmed that Apatosaurus, and therefore also Brontosaurus, was much more similar to another dinosaur from the same area, which is called Diplodocus, and not to Camarasaurus. And Diplodocus has a very different skull from Camarasaurus. It's much more elongate and looks almost a bit horse-like. So then the image of Apatosaurus and therefore also Brontosaurus changed, and the skull in drawings and the head in live reconstructions of this animal also changed.
Yeah, you go from this kind of bulky,
yeah, exactly,
I guess more bovine,
yeah,
skull maybe, to the longer horse, maybe giraffe-like, I don't know, narrow-headed. Yeah.
So the Brontosaurus we revive now looks very different from what the popular image of Brontosaurus is, actually.
And so thinking about the skulls, so we've come to the decision that have we ever found a Brontosaurus skull now?
There are rumors about the
Oh.
Brontosaurus skull, but there is no definitive confirmation yet of a skull for a Brontosaurus skeleton. So we cannot tell for sure yet. We do have an Apatosaurus skull, though, and I saw pictures of that proposed Brontosaurus skull. I actually also saw a cast of that proposed Brontosaurus skull, and it does look more like these Apatosaurus or Diplodocus skulls than to a Camarasaurus, which makes sense because also all the rest of the skeleton looks much more like Diplodocus or something similar than to Camarasaurus.
So what happened when I was growing up, early, in the 70s? I remember growing up 70s, 80s, Brontosaurus. Why
Yes.
did I grow up learning that there was a Brontosaurus?
I think it has a lot to do with the very early history of Brontosaurus. Brontosaurus also is a very iconic name. The thunder lizards really explains very well how big and how massive this animal was.
Right.
And the fact that it was the first or one of the first animals that really showed the shape of a sauropod, because it was one of the first that was reasonably complete, kind of got this name stuck with this figure of a sauropod, of a long-necked dinosaur. Also, when this synonymization was first proposed, that Brontosaurus would actually be called Apatosaurus in 1903, the researcher who did that in a journal, in a scientific journal that was not disseminated very widely. So it took some years until the entire scientific community was aware even of this research. Then within the scientific community, it changed relatively fast to adapt Apatosaurus as the real name for Brontosaurus, but still there were some that continued to use not Brontosaurus as a genus,
Right.
but the name Brontosaurus as a popular name for sauropods.
Right. Kind of the same way that some birds have a scientific name and a common name, or
Exactly.
yeah.
Exactly. So it got kind of readapted for the entire group of sauropods, even though that's scientifically not very accurate.
Right. And so with this paper coming out, since the entire scientific community over the 1900s took a really long time to adopt it and then change it and accept it.
Yeah.
I'm kind of comparing this, and I'm sure this comparison is going to come up a lot with the change in the designation of Pluto as a planet. It's you get a name, the name goes away. Your scientific designation is given, and then it's taken away. In the case of astronomy, there is an astronomical union. There's a group of scientists who actually got together and voted at a meeting and said, no more Pluto the planet, right?
Mm-hmm.
Is there a paleontological association that will get together and vote on this? Are you going to be subject to just review and commentary on this paper? What are you going to be looking forward to once this paper comes out?
There is no such a thing as in astronomy. There is It's called International Code of Zoological Nomenclature. This is a group which kind of oversees the naming of species and gives rules to that and everything. But that's more on a species level, and they only really have to decide upon things like, does this species, is a certain species fixed to a certain skeleton, which is the reference skeleton for the species, or should that be changed, or stuff like this. Mm-hmm. The matter of Brontosaurus being valid or not does not need a decision of this international code. What will happen, I think, and I hope also as well, is that there will be a scientific discussion going on and starting and going on about not only this subject, but probably also about how we reach this conclusion. Mm-hmm. This is the way how science is done, and it might also take some time now that everybody agrees if Brontosaurus is valid again or not.
Right. Are your statistical methods sound? Is going to be a big debate, right?
I guess this will be a debate. The fact that we use two different statistical methods that got to the same conclusion with different approaches, mm-hmm. In our opinion, gives strong support to the revival of Brontosaurus. But I know of other researchers already that do not completely agree with that. So I know there will be a discussion, and I am looking forward to it. I wonder, or I'm curious to see their comments and their results.
Do you know what kind of criticisms people have of the result that you have?
It's mostly, or the one I know is mostly about these statistical methods that because the problem is that the result of our analysis was basically the part of the tree of life where Diplodocids sit. And if you take this branch of the tree, you see Brontosaurus and Apatosaurus as two branches very close to each other. Mm-hmm. And if you only see this, the assumptions that the two are different genera and the assumption that Brontosaurus is the same as Apatosaurus just depends on where you put this border in the tree. So from the tree alone, you don't have conclusive evidence that they are separate genera. But our problem was that we didn't have the species there, but single skeletons. So in some way, we not only had to establish borders between genera, but also between individuals and species. So a numerical approach or a statistical approach to this problem was the only way to solve this.
Yeah.
And if we wanted to do this in a consistent way for the entire group of Diplodocids, the conclusion that Brontosaurus is valid is the only one we could get.
Right. It's just interesting to me from a biological perspective. The classification of organisms mm-hmm. is something that is, it sometimes seems so vague. Like a species is, or a subspecies could be, mm-hmm. you know, when is it able to interbreed with another? When is it completely independent and its own specific organism? You know, and we look at these things, animals from the outside in, and try and decide who is who based on, living extant organisms. Oh, coloration, song, call, ecology,
Yes.
all sorts of things. And then in the paleontological world, it's bone characteristics and how are they built
Yeah.
and what did they look like, and how do you really come to decide the separation and the classification?
Yeah, I mean, having only the fossils, we cannot make tests of interbreeding or see if
Yeah.
they can have fertile offspring. So really very detailed comparison of the anatomy of the bones is the only way we can address this question. But it also takes like the initial idea of Charles Darwin that new species are formed by the accumulation of new traits. And the statistical approaches that we used have this as a basic idea. So the more different two skeletons or also two groups of skeletons, which can be species or genera, the more different they are, the further distantly related are they. So you can have differences among skeletons, individuals of the same species, but only to a certain amount. And then at some point you have to make the distinction between species.
Yeah.
But also there only to up to a certain amount of differences. And at some point you have to make a distinction between species and genera.
Right.
So yeah, we try to do this in a consistent way in Diplodocids. The numbers that we got from the statistical approaches, they cannot and should not be applied to different groups exactly as the numbers, but the methods can.
Right.
So yeah, it's this consistency that we try to have within Diplodocids that led us to conclude that Brontosaurus is different from Apatosaurus.
So you think that this the methodology that you used in coming to this conclusion and in this paper, could it be used to standardize across genera?
That's a bit my hope, because that would also allow to kind of compare better and understand better what the genus is.
Yeah.
If this distinction would be more standardized. But it's to do this analysis, it's a lot of work. And
supercomputers.
Sorry?
We need supercomputers to crunch all the numbers.
Yeah, and you need a lot of time.
Yeah.
And you need to see a lot of material. But yeah, I think for like larger scale revisions of entire groups, as our study is, this should, and I hope it will, become a standard or something similar at least.
Yeah. For a final question, I'm just wondering, what was your decision process in deciding to publish in PeerJ and going open?
It was really just that. That was the main issue, because I thought I did so much work doing my PhD together with my co-authors, also after the PhD, that I did not want to keep that for myself or just for a restricted audience. I wanted that to be available for anybody. That was the main reason. The second reason was that such an extensive paper is very difficult to get published in all its length in a printed or in a print journal.
Right. It's this is a massive paper.
Yes, it's almost 300 pages.
Yeah.
So
it's a book.
it's a book. And I'm very happy that PeerJ agreed to have it, and with all its images and tables more online, not in the paper. But yeah, it's a very extensive piece of work, and online publishing was basically the only way to do it.
I think that's really a fascinating. It's a neat evolution in publishing, because for so long we have been just kind of limited to the printed page, and so that limits the extent to which you can delve into something and show it to people in the way that you'd like. And so you would have to have published this as a standalone book or a standalone journal issue.
There are some journals that accept such extensive works, but there are very few, and some of them are not very well distributed.
Yeah, and online, this is the kind of anybody can see it, and anyone can see what you've done and read the whole thing, and comment and share it. And there's, it's just I am looking forward to seeing where the conversation goes about this.
Yes, me too. And online is the easiest way to follow it, and the fastest. Yeah. So, it allows really also basically conversations online right at the specific paragraph where questions arise. PeerJ, for example, which is very interesting. Yeah. And only like this also we could present all our data that was behind the study, and we could really explain in detail what we did and how we did it, so that people can understand and can actually reproduce the analysis if they want to. And I think this is especially important in this case because it's it has this maybe controversy outcome. So we have to explain well how we got to this conclusion.
Right. And do we accept Brontosaurus as its standalone species or not? A standalone genus, actually.
Genus
yes. And species.
It was always a standalone species, but standalone genus.
Yeah. Wonderful.
Well, the evidence is out there. I guess some will agree, others will not. We will see.
Well, I think that's one of the best parts of science. You do your analysis, you do your work, and then put it out there and
see what happens.
Yeah. Thank you so much for your time today. I really appreciate it.
Yeah, well, thanks for your interest.
You're welcome. It's dinosaurs, and it's awesome. Yeah.